We have one objective in this section: use trigonometric substitution to solve an integral. You can use trigonometric substitution to evaluate integral involving the radicals. We have three types of the radical form. The objective with trigonometric substitution is to eliminate the radical in the integral. You do this by using the Pythagorean identities. Look at the first pattern. It's a radical of a squared minus u squared, where the a is constant and the u is variable. When we have this, the first pattern, we use the first identity. Because 1 is constant. It's constant minus variable. Constant minus variable. For the second pattern, is constant plus variable. Constant plus variable. For the third pattern, is variable minus constant. Variable minus constant. Now look at this example. How we going to eliminate the radical? For a greater than 0 and let u equal to a sine theta, where the theta is between the negative pi over 2 and positive pi over 2. For this pattern, radical a squared minus u squared is the first pattern. So our variable will be a sine theta, where the a is constant. And we substitute the a sine theta into u, and we factorize a squared, where the 1 minus sine squared theta is cos squared theta. And the radical a squared cos squared theta, we can simplify the square. So after we simplify, we just only have a cosine theta, where we have eliminate the radical. If we have the first pattern, radical a squared minus u squared, we let u equal to a sine theta. And if we have a second pattern, radical a squared minus u squared, we let u equal to a tangent theta. And for the third pattern, we let u equal to a secant theta. Once we have u equation, we can use trigo rule. First, scale the triangle out and apply the trigo rule. From the first one, we have u equal to a sine theta. So we can say sine theta is equal to u over a, where the sine rule is opposite over hypotenuse. U is opposite and hypotenuse. And to get the adjacent, we use the Pythagorean theorem to get the adjacent. Where the adjacent of this case is our pattern. Look at the first example. Let's say we have integrate to 1 over x squared radical 9 minus x squared with respect to x. So for this case, it is impossible to use the change of variable method. First, identify the radical form. The radical form is of the form of radical a squared minus u squared, because the 9 is constant and the x is variable. So it's matched the first pattern. So the u is x equal to a sine theta. And the a is equal to 3. You try to compare these two. So the a is equal to 3 and the u is equal to x. So our x is equal to 3 sine theta. Once we have determined the x equation, from the previous step, we have x equal to 3 sine theta. And we differentiate the x equation with respect to theta. We have dx d theta equal to 3 cosine theta. And we move the d theta to right side. We have dx equal to 3 cosine theta d theta. And for the radical part, we have radical 9 minus x squared, where the x is equal to 3 sine theta. So we simplify this radical form, where the x is 3 sine theta, and the x squared, we squaring both sides, we have x squared equal to 9 sine squared theta. And we factorize out the 9. And we can convert the 1 minus sine squared theta to cosine squared theta. And lastly, we simplify. We will have 3 cos theta. Because the radical 9 is 3 and the radical cosine squared theta is cos theta. Okay, and after that, we scale up the triangle. Based on this x equation, we have sine theta equal to x over 3. And we apply the sine rule, where the sine rule is opposite over hypotenuse. Opposite is here, and the hypotenuse is 3. And how to get this adjacent? We use Pythagorean formula. And we obtain the adjacent, where the adjacent is our question. Okay, so now based on this question, we perform the change of variable. we change the x variable into the theta variable. So where the x squared from here is 9 sine squared theta, and the radical 9 minus x squared from here we have simplified. It's 3 cosine theta, and the dx here 3 cosine theta d theta, and we can simplify, and the 3 as well. So we have radical 1 over 9 sine squared theta with respect to theta. So we can factorize out the 1 over 9 because 1 over 9 is a constant. And we have 1 over sine squared theta, where we can convert the 1 over sine squared theta to cosecant squared theta and integrate the cosecant squared theta with respect to theta. We use the basic integration rule in our first section. We have negative cotangent theta, and since this is an indefinite integral, so we produce general solution, and we write plus c. And what is the cotangent theta? Based on this triangle, the cotangent theta is adjacent over opposite. So we have radical 9 minus x squared over x. And after we substitute into our cotangent theta, we simplify our answer.